Hello, waiting for the screen to pop up. Oh God. Um, my microphone audio levels are a bit too high, I guess. Well, I don't remember how to reduce it. Let's see. Yeah. Hmm. Is it vehicles? I guess it's vehicles. Hmm. Hopefully this should. Oh, never mind. Hopefully this should be good enough. Do I have to save this? I don't see a save option. I guess I just close it. Hopefully this. Yeah. Uh, this sounds good enough. Okay. I was just checking my stream check. Oh, I just closed it. Let me just open it real quick. Um, yeah, perfect. Okay. I can see myself. I can hear myself, which is good. Now, hopefully, this switches the screen. Oh, it didn't. Hmm. Oh, it was okay. The other way. Hopefully, you should be able to see the screen. Let's check. You can see the screen. Yeah. Today is 14th March, 3.5 months in already in 2026. Okay, let's solve today's daily leak code problem. Is my screen still visible here? Cool. Ah, okay, day 14. 1415, the kth lexicographical string of all happy strings of length n. Okay. Hmm. A happy string is a string that consists only of letters of the set A, B, C. Okay. S of I should not be equal to S of I plus 1 for all values of I from 1 to S dot length minus 1. String is one index string. Hmm. Okay. For example, strings and this are all happy strings, and strings this, and this are not happy strings because they have A, consecutive B here, which is not allowed, which is not a happy string. Given two integers N and K, hmm, consider a list of all happy strings. Do we have to like generate all the possible combinations and like then find the kth string or something? Let's see. Given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. Lexicographical order basically means A, B, C, basically increasing order, right? Like A is the smallest, then B, then C. Hmm. Return the kth string of this list or return an empty string if there are less than k happy strings of length n. Okay. This feels like a recursive backtracking kind of problem. Basically, we have three options. Let me check the constraints first. Oh, n is still 10 and k is still 100. So yeah, this is for sure a recursive like backtracking kind of problem. We have three possibilities A, B, and C. That is 3 to the power of n. Nah, 100. Right? Because we want the kth string. And n is just the size of the string. So we have k different options. Yeah, 3 to the power of k, which is 3 to the power of 100. Ah, hmm. Can we memorize this? Uh, why I'm scared or second doubting myself is because this is a string, right? And uh, it's like I will get a Emily, basically memory limit exceeded. Ah. Mhm. If I try to basically store all the states of the string, oh, that's like the very brute force. What is 3 power 10? Yeah, 3 power 10. Hmm. This is very small. Okay. What my idea was to basically generate all the possible combinations, right? Hello? What? Ah, okay. Why is Leetcode being weird today? Okay. Hmm. Basically, what I wanted to do is suppose we start with A, right? And then move on, we have B, we have C. But instead of A, we can also start with remove this character A, start with B here, then C, then A, something like this, right? And have a condition where we check where two adjacent characters are not same. But the problem here is the time complexity. This, I guess, will clearly, but I want to at least give it a shot. I want to try because I think that is the solution. Should I check topics? It does say string and backtracking, right? I weekly 24. Let's see. Generate recursively all the happy of length n. I guess yeah, it is 3 to the power of 10 because we have n places. Yeah, I was wrong about k. We have 10 places and 3 options. So it will be 3 to the power of 10, which is well within our limit, right? Then, so, hmm, I was thinking of like an early optimization kind of a thing, where we already generate all of these what do you call strings in lexicographical order, and then uh, when k becomes like basically every single time we hit the nth character, we reduce k by one, and then when it's zero, return the actual string. Otherwise, return a normal empty string. But yeah, this is another way where we can store these strings in a list. We can store these strings in a list and then sort them lexicographically and then return the kth one. Let's see. Public, I want to keep it a string type, right? String generate um happy strings, a bit of a long name, but okay. If n equal to zero, what do we do? Let's say an array list of strings. Let's call it answer, and let's not declare it here. Ans equal to new array list. Oops. Hmm. If if I equal to n, then answer dot add. Basically, what this means is that we have finally reached the end point, right? We have finally generated a string. So we need int I, that is our add pointer, and then a string builder sp as well. I'm just copying this. The new string builder, and then I, which is zero, right? Because it's the starting index. Sb dot to string. Hmm. How do I want to write this now? Because we have three options. Either start with A, so I can write it like uh, sb dot append sb dot append A, then recursively call this function sb and then I plus one. Oh, but we also need to keep a track where this is not same, right? I minus one if I is greater than equal to zero. Whoops. Uh, and sb dot char at whoops I minus one is not equal to a. Then sb dot append this and then recursively call this. Else, similarly, if I is greater than zero, if I is the first character, we should try adding all ABC once, right? ABC, AB. Hmm. And then here SB dot delete char at SB dot len minus one. If I is greater than zero, then do this. Okay. Similarly, this should be same, right? Hmm. I'll just change the character. This feels this doesn't feel right. Hmm. I don't know about this. Not because of that. Um, this dot this can dot out of println when I do this. Hopefully, return empty string. Okay. A comma B comma n is equal to 1, right? Then why is it printing this? I want to check for this, right? N is 3. Oh, it should be equal to n minus 1. Oh, no, it should be equal to n. A, B, C, A, C, A, C, B, A, B. Okay, it went here, then A, B, added A. Why is it adding 4 characters? Is it in one? I don't think so. No, that just messed up even more. Hmm, yeah, I need to check. I think my idea is correct, but most probably, um, the implementation might be a bit funky. Missing backtracking and you never return the cage frame. Okay, I know that, but yeah, I was not sure about this part because I didn't know how to handle the case where you append the first character, right? Oh, I just had a realization. We never need to check. We do. And so that, and this. That's what I did. I never do. Yeah. Oh no. I forgot to delete. Oh no. I forgot to delete the characters here. SP dot len -1. Whoops. Oh, copy paste. Okay, this should be this should work, right? Okay. ABC. Oh wait, hold on. This is ABC perfect. This is ABC perfect. This is ABA, ABC. Where is it? Yeah. ABC, ACA, ACB, BAB, BSC, BCA, BCB, CAB, CAC, CBA, CBC. Perfect. Okay, so I was right, but this is so silly. This is so silly. Okay. Okay, so I just need to check whether or not if just write a ternary operator instead. If huh, what is this? K is less than answer dot length, then uh then return answer dot get K. Else just return an empty string. This should work, right? This should be good. This is size. Yeah. What? K equal to 3. Oh, it is one base index. So yeah. It is one base index. Okay, this is right. Okay, correct. Everything looks correct. Time complexity is 3 into 2 to the power n minus 1. Okay, so explain the time complexity. Yes. How is it 2 to the power n? I thought it should be 3 to the power n. Why? Because we have one, two, and three functions, basically, three characters, right? So generating all of those three characters. Oh, oh yes. If previous equal to A, then choose B comma C. Basically, we only have two options. Wow, this was hmm, hmm. I need to be careful here, right? Okay, this was smart, actually smart. It is 3 times 2 power n, which is basically O of 2 power n. 2 to the power n. That was actually smart. Okay. Hopefully, Yeah, 2 to the power n, which is 10, which is nothing like 10, 1000. So yeah, 1024, right? 10 to the power 3. We should be good here. Should I just submit it? Screen. Okay. Always okay. Hmm. Okay. Let's hit the submit button. Hopefully, it passes. It gets accepted. Boom. Nice. Okay. 11 milliseconds. You will have solved it in a better way. I'm probably guessing it's a like iterative method. Mine is recursive. Obviously, it's going to be slow. I don't expect anything like faster from my code. But yeah, let's see. Ta-da-da. Wait, what? Ah, okay. He just looped over it like the allowed characters. Basically, he has stored a comma b comma c in allowed characters, I believe. Yeah, that does make sense. Yes, and just basically iterate over these characters. That was a thought that passed my mind. Basically, writing this repeated for work. I could have written this iteratively, but anyways, it works. And yeah, a kind of a early optimization. When this hits k, we can directly return the string, right? Otherwise, return k. That that's something I guess I sell it, or I sell it in my head. I don't know. If I equal to n, right? What that means that we found uh what do you call? Let's first make it a string. We found the we found a string, right? A valid string. If k equal to 0, we can directly return sv dot to string here. Otherwise, uh, we don't even need to store it in a variable, right? Otherwise, just return null. A bit of like micro optimization, if you say, if you want to call it. Um, hmm. If this is I equal to n, then we first reduce k. Also, k is one based index, right? Uh, if k equal to 1, easy fix. This dot k equal to k. Whoops. If k ever becomes equal to 1, then just return the string, otherwise return null. Hmm. If uh, return sb. Okay. I need to check where it doesn't have a null string inside of it. Let's see if this works or not first. Mm. Oh my god, sb dot to string. Yeah. Or should I store this in like variable or something? Yeah, this will give some yes. String result. This is SB, right? Equal to empty string for now. This will return a string. Let's just store a string or a null. We don't know yet. This will also return the result is this. This is this. Okay. Now, if result is not equal to null, then return result. Otherwise, return an empty string. So, yeah, we are returning a string or a null from here and checking whether or not it is null or not. If it is null, it means that it is an empty string, right? Okay, okay. I'm getting empty strings, but I'm pretty sure there is. Oh. Yeah, I get it. Why this is wrong? Um, hmm. String answer equal this. Return answer. Yeah, this should work. Like just store the solution given by this function into an answer variable. Okay. Hi. What? Should I just already make this one base index? So if this equal to 0, then only return. That shouldn't make any difference. Yeah, this doesn't make any difference. Hmm. Let's check. Yeah, incorrect A handle. Recursion. Okay, so that was correct. Is it like when k equal to 0? Oh my god, is it just I had to do k equal to 0? No short, right? Okay. This I had it in my mind, but I didn't say it out loud. That's why I basically tried checking this null condition at the end. I was a bit confused whether or not I should check it here itself or not. I could do it before this deleting, or I could do it before deleting. It doesn't really matter because already have this result, right? But let's keep the format simple. Uh, Return result. It's null. Oof. Ta-da-ta, ta-da-ta, ta-da-ta. Okay, does make sense. Hmm. Small improvements. Oh, beautiful. Oh yeah. If answer is not equal to null, then return answer, else an empty string. This should work. Yeah, this is correct actually. Now, what I want to do is reduce this manual work that we are doing, right? Like generating A, comma B, comma C, checking it every single time. Instead, what we can do is store this A, comma B, comma C in an array and then iterate over it, right? For example, this allowed list, we can store it here, and then just iterate over it. But then how can I remove what do you call it? The else part, right? Because how uh, is greater than else three equal to- okay, but what if C is less than zero? Then what is my question? Uh, basically, it's on the first character, right? I is on the first character. I's value is zero. Then what? Let's see if this works or not. Yeah, that's what it's about. Hmm. Let's see. Did return an empty string? Yes, it did. Yeah, which obviously makes sense because like I'm literally checking basically this code block of code will uh generate all the strings only when I is greater than zero, right? Or basically this block of code will execute when I is greater than zero. That's when basically we can check this condition. Hmm. If okay, if this is the thing and this is same, then I see I just simply add append. Yeah, this does make sense. Like if I have whoops, okay. If I have an int char allowed list int char char okay char allowed list a comma b comma c, and then just iterate over it, right? Simply iterate over it. Yeah, just I'm just going to write it separately. For char c in allowed list, this is already char array, so yeah. Anyways, um, what do we want to do? Basically, this, yeah, sp dot append c and just check if I is greater than yeah, if I is greater than zero and c is equal to sb dot char at I minus one. If this is true, then continue. Move on to the next, which is like if it's A, move on to the next, move on to B. If not, just append that character and just recursively, if you can try other different combinations, backtrack. Oops. Yeah, just remove all this manual work. Backtrack, check for different combinations, and then just if we find a valid result, that is like if only if k is equal to zero, then we return the string, right? If this is true, and this result is not equal to null, return the result. Otherwise, just return null, which means that we don't have enough uh possible values of length n to generate like the kth string, right? Which means return an empty string. This should work. Perfect. It did. Hopefully, this should be faster than the previous one. Yeah, it is. And I get it why, because we don't keep on generating all the possible values, right? As soon as we hit our limit, which is k, we just instantly return the value. And but the what do you call it? The time complexity will still be 2 power n. Why is that? Because if k never reaches equal to 0, then basically you have to generate all the possible values, right? Which is 2 power n. And basically the case where this function will return null. Huh. Yeah, but this is still faster. A bit of note, I won't even call it a micro optimization. This is a very good optimization if you know it. It's like good to know. Like that made it so much faster. From 11 seconds to from 11 milliseconds to 1 millisecond. So yeah, that's a lot of time saved. Time saved right there. Hmm. I'm going to create. Oops. I am going to create a folder for this. Basically storing both the solutions that I wrote. Whoops. Where is the previous solution? Oh, I do want to check the time complexity for this one especially. Oh, wait, no. Where's the time complexity? Wait, what? Enumeration. Yeah, yeah, yeah. Yeah, current complexity is O of K. Often is this, I believe. Yeah. O of K is way faster than. Oh no, what? Characters are using. Such, consider calculating characters directly using division and modulo operations to skip entire subtree instead of iterating. What does this mean? Okay. In this problem, what is the time complexity for this code? Hmm. Okay, let's see. Hmm. Before that, I want to check my string once if everything's fine. Everything's loaded. Let's see. Given two integers and then k subtree instead of iterating. That's the same. A comma b comma c, and then just iterate over it, right? Simply iterate over it. Yeah, okay. The stream's going good. I don't see any issues yet, but yeah, let's see. Solution. Give me the latest one. Okay. Da-da-da, first character, three next character. You can not increase the total happy string is three into two value. Basically, okay. Uh, hmm. And into two power n. What? Generate all it should be only two. Yeah. I get it. Two power n is basically like bigger than n, right? So we consider two power n, but yeah, accurately, it is, I guess, n into two power n. Okay, spent a lot of time on this problem. Almost 40 minutes, right? I just checked. Yeah, almost 58 minutes over it, right? Oh yeah, yes. Okay. Oops. Okay, let's solve our contest problems. Now, I believe I have solved the first two problems for this particular contest. Yeah, I have. Let's just go for the third one. The third and the fourth problems are usually a bit scary. 3863. Let's just open it. 3863. But yeah, I'm obviously. Oh, what? 18.1% acceptance rate. 83,000, almost 84,000 submissions, and 15,000 got accepted. 15,000 out of 83,000. Question three. Oh, uh, okay, never mind. Okay, let's read the problem at least. Let's see. 3863. Minimum operations to sort a string. Ah, you are given a string is consisting of lowercase English letters. Okay. In one operation, you can select any substring of S that is not the entire string and sort it in non-decreasing alphabetical order. Non-decreasing means increasing alphabetical order. Another interesting. Okay. Return the minimum number of operations required to make S sorted in non-decreasing order. If it's not possible, return them. Ah, ah, okay. Now you can select any section of this. It is not the entire string and sort it in. The answer should be at max 2, right? Or am I missing something? 2. Yeah. Sort substring to G to GO. We should be Gucci. Car. So ACR and then select this. Yeah, this is an edge case. Let and correct and the whole string and the end answer is 1. Yeah, that does make sense. If it's connected on some person, that's true. If no MN exists, please can you proper profile? Mm. Yeah, I was going to say I should have said this 3. I thought the max answer could be 3 in a case, but then didn't say it out loud because I thought the 2 and thought 2 would be the max. But yeah, anyways. Ah, yeah. It's just find the minimum character. What was the uh rating? Not rating. The points for this problem. 5 pointer. But okay. Anyways, and let's keep it at int min equal to integer dot max value int max equal to 0. Okay. Okay. For char c in s dot to array min equal to max dot max min of min comma c minus oops 0 and max will be x. Okay. If min equal. Oh wait, these are characters, not numbers. A, right? If this is equal to s dot cat at I minus A, or mx equal to s dot cat at and 10 equal to s dot len n minus 1 n minus 1 minus a. If this is true, then directly return 1. Else, if hmm, if we have two distinct these characters, right? When is it not possible? When I think only when n is less than or equal to 2. That's the only time when we cannot select an entire string, compare it, and then put it in the end. If n is less than equal to 2, return minus 1. Otherwise, oh, this should be 0, my bad. What if like A is in the middle? When can we have the three case? Access improper prefix. Okay, basically, what like one operation to solve this, one operation to solve this. So else, it should only be else return to. When is the minus one case for? If S is already sorted, answer is 0. There is a condition to check for entire equal to 0 plus plus while entire equal to 1, I is less than n if s dot char at I minus 1, if this ever becomes greater than non-descending. Hmm. If this ever becomes greater than s dot char at I minus a, then break, brother. Okay. Just check if I equal to n, also increment the pointer. If I ever becomes equal to n, yeah, return 0. What if it was um DGO. Whoops. I'm trying to think when will there be a case where this will be equal to 3, right? The answer will be equal to 3. Ah, okay. When will the case be 3? Hmm. I think these are the only cases. I don't, or rather, I cannot think of a case where the answer will be 3. Or let's just check. Yeah, DCAB. Yeah, just saw this ACD and then basically DCAB to ACD B to ABCD. So 192, 192. Um, okay. Hmm. Vulnerable distinguished place characters. Let me validate. Mismatch equal to 0. Okay, this makes sense. We take a set and then variable mismatch for this, which is the original string. If this is not equal to this, mismatch plus plus set dot add. If set dot size is greater than 1, what? I think this should be good enough. Albert Mixing will answer will be 3 your hurts. No, right? Yeah, that's what I thought. Gave a content. Shit. Um, this doesn't matter like a lot. It's just often because of this of n plus of n, which is two times of n, basically of n, of two times n. Oh yeah, this is a good case. Okay. Hmm. Nah, this will pass. Okay, no, no, just check this. A, B, A, B, C. Interesting. Okay, I think I should submit it. Yeah, there we go. Why does this need to sort this to see from already? Hmm. Yeah, I mean, I do get it why this is wrong, like solution is wrong, but because for sort DNC, which becomes EDC, PCD, um, CED, and then CDE. So this does take 3 steps. What if the string was AD, BC, or not? AD, BC, D, E, F. Okay, so take this and this, sort it, C, or not, E, C, D, F. Or if the minimum character is at the end, that's the only case where it becomes 3. Because then you have to fix this position, which is C comma E, C D E doesn't, oh, it's fine. And then C D, basically here, oh wait, what? C D, yeah, because we could choose these three, right? Yeah, that's why this is equal to 2. But, oh, okay. This is a special case, right? If n equal to 3 and min equal to s dot char at 2, basically, n minus 1. Return 3. This is the only case where we need to return 3. 1267 out of 100. 1291. Ah, let's see. I'm submitting it. Damn it, God damn it, God damn it. G, G, G. Okay, so I think there is like a proper way to solve this. I should not just keep guessing. Simply, I try to minutes right. Yeah, just a minute. Let me check if there's any YouTube video. Probably I will. Okay, I will probably watch Larry's video on this, but yeah. Hmm. Let me change my screen. This should be visible.
This is me going with Q3 of the weekly contest 492 minimum operations to sort a string. This is definitely a tricky one. I think this is what I would consider ad hoc, which just means that it doesn't belong in anything, or miscellaneous. This is what I would consider ad hoc, which just means that it doesn't belong in anything, or miscellaneous if you prefer. And it is just a logical problem. And I am going to bring up the drawing board as we thought if I could find my drawing pen. Well, I have to put it up on the screen. And the idea here is that, well, you can do anything in 3 moves. Because there are a couple of ways you can think about it. And just to be clear, I got 2 wrong answers on this because I kind of had some idea. I knew the 3 moves part, but I wasn't able to, figure it out. And we'll talk about this now, right? Well, if there are 3 moves, that means that you can break it down into cases, right? Which means 0, 1, 2, and 3 moves. 0 moves is just pretty straightforward if it's already sorted, so we don't have to, we'll go over the code, but it's pretty straightforward. 1 move means that, one move means that one of the characters already in the smallest character is in the beginning, and then the second character or the last character is at the end, right? Because then now, if you have a string that looks like this, and because you cannot choose the same string or the whole string, you want to pick almost the most string that you can, which is to say, oops, change colors. you make one move, which is either this move or this move, not including the first or last. And if you do that, then you're Gucci. Okay, two moves. Then how do you do two moves? Two moves is, and this is where I got wrong during the contest. I was trying to figure out, like, maybe I should do two moves, maybe I should do three moves. Which one is easier to figure out and implement? And I did this wrong a couple of times, but it turns out that two moves is just, well, there are two ways to do two moves. So that's not that bad, right? It's basically, you do, it's similar to this thing, right? Which is that if you have a string, and this is like a sequence of string, you can either go this first, and then after that, swap the rest, or the other way, right? You can swap this first, and then swap the head. And, because in the greedy way, you want to choose as many things as possible to sort. So those are the two ways. So if you still cannot sort it in these two ways, then it is a three-move problem. I thought that maybe during the contest, and this is not correct, everything I said so far is correct, and that's how you would solve it, because then now everything could solve in three, because in the worst case, you could say CBA is a good example, right? Because you have to swap these two. Well, it doesn't matter which one you swap, because then now you have to swap the other ones to BAC, and then ABC, right? Swap these two. So that takes three moves, right? And you could say that this sequence can solve every three moves. And I thought maybe there's a logic that I can use here, but it turns out that the logic is just doing the two moves instead. Yeah. Oops, I got two wrong answers because I didn't watch the live portion. But this is how I did it. There's the impossible case that I forgot to mention, which is actually here, which means that because this is the only way that is impossible is because you have two characters, so you cannot choose both of them, and they're just never swap. So okay, so if it's already sorted, and we pre-calculate the sorted string. If it's already sorted, we
That's what I did. That's what I did.
turn zero, right? If there are two characters and it's already not sorted, we're still not sorted.
Yeah, we have okay, so I should have put this condition not here, but here, right? If this, oh no, here. If this is 3,
Then it's negative one.
hmm, this will return -1, which is a problem. If we have the minimum at the start, then it will be 1. For example, in this case, right? G G A G G J G. We had this sorted part here. That's why we could just directly do this. So yeah, just the ordering mattered here. Oh, what? Unreachable state. Um, yeah, wait, I need to fix this. Well, if it's not the start or the end, it's somewhere in between. That's when you return to. I think I will just write it like this. Whoops. Huh. Return to. Hmm. Probably that's the way. Yeah, that this does make sense to me.
Otherwise, yeah, if the first character is already the shortest or the earliest character, then you just do one move, and then this is the one move. And this is just the implementation of. I was too lazy to name them, but sort the string not including the first character, and then this is sort the string not including the last character, right? And like I said, there's only two ways to use them in two orders, and that's basically what I did, right? So if could probably implement this a little bit cleaner as well. And
If what? So this should not including the last direction. Ah,
You do two moves.
Hmm.
Otherwise, everything can be done in three, and that's it. All these operations are either linear or constant. Actually, mostly probably linear, right? This is linear. Is linear. This
Okay. I just want to check. If I hit submit, is there any case that I'm missing out? Hmm. Else if it's um let's define public if sort except first. Oh, sort except last string is okay. S equal to s dot char at 0 plus s collections dot sort s from 1 to s dot length. I guess is there a function like this? But rather, is there a function like this? Is so, yeah, char array equal to s dot to char array. What does this mean? Collections that can I convert it? I can. Interesting. Yeah, dot length. Return new string. Yeah, that's yeah. Do this, but include the first character and exclude the last character. So sort. Oh God, except first and s equal to sorted dot equals or ah, first. This is last. Then return to Now what is sorted? Char sorted is equal to char array arrays dot sorted string sorted. Can I do this? Equal to. Oh my god. This is arrays dot arrays dot sort. Ah, this is so dumb. Okay, three wrong solutions. Ah, okay. 3864 minimum cost to partition a binary string. Okay. 6 pointer problem. Hmm. Minimum cost to partition a binary string. You are given a binary string as and two integers ENC cost and flat cost. Okay. For each index I, S of I equal to 1 indicates that the ith element is sensitive, and S of I equal to 0 means that indicates that it is not. The string must be partitioned into segments. Initially, the entire string forms a single segment. For a segment of length L containing X sensitive elements, that is number of ones. Hmm. If x equal to 0, the cost is flat cost. If x is greater than 0, the cost is L into x into ENC cost. If a segment has even length, I. Why? If a segment has even length, you may split it into is split it into two contiguous segments of equal length, and the cost of this split is the sum of costs of the resulting segments. If a segment is you may split it into two contiguous segments of equal length, and the cost of this split is the sum of the costs of the resulting segment. Okay. Return an integer denoting the minimum possible total cost over all valid partition. This is a difficult problem. This is a very difficult problem. Denoting the minimum possible total cost over all valid partitions. Okay. I cannot figure out whether or not this is like going towards DFS or BFS. I'm thinking of BFS because it is a minimum possible total cost, but DFS because we have to split it into segments, but we don't have any fixed like K segments or anything. So I think it's not DFS and probably BFS. Like we need to maintain some states. The entire string show S this has length 4 and contains two sensitive elements given a cost of this. Since the length is even, it can be split into 1, 0 and 1, 0. Each segment has two lengths, has length 2 and contains one sensitive element. So each cost uh, is this, giving a total of 8. The both segments into four single character segments yields the segment 1 comma 0 comma a segment containing 1 has a length. Okay, so when the length of a segment is even, that's the only time we can split, right? And if it's odd, we stop there immediately. Return an integer given the minimum possible total cost over all valid partitions. So the total cost here is what is x? X is the number of sensitive elements present in L. If x is greater than 0, cost is L into x. What is x? You know, L also we know L will be odd. L will be odd. X is 1. L is also 1 here. And ENC cost, which is 2. So this is 2 plus what is flat cost 1, which is 3. So per equal go 3. HMS length 921 cents. So each cost is uh, this is 2 plus 1 plus 2 plus 1, which is 6, which is minimum total cost. Okay, that's how we calculate. So basically, we need to maintain like a global min variable, which is integer dot max value while s no whoops int n equal to s dot length while n is greater than 0. Uh, we can split uh we can split only when this is even, right? How do we maintain that? Is this recursion? Like, do we have to solve it recursively and not using a while loop? We have from this to this, and then another function which goes ahead from basically I to j and then j plus 1 till n, or rather n minus 1. But yeah, I to j and then again divide I to another smaller j and then j plus 1 to that will be the new n. I think that's the move. And then just define a global min variable. Okay, so return DFS. I'm just not even going to think about naming this. For now, S I will be 0, J will be n minus 1. Let's keep it inclusive, or rather not. Uh, yeah, keep it inclusive. Public. Oh God, what's n? Okay, immediately discard it or not. We are reducing, right? Reducing. I'm just going to write it. I'm just going to write it. Let's see. Public long. This should be long. DFS string s int I int j if I less than equal to j. That means there is no more segment, return 0. But if there is a segment for int I equal to, oh no, int k equal to I, yeah, k is less than equal to j, k plus plus, just iterate over it, right? Um, this will be a long result equal to 0 L, yeah, result plus equal to DFS of just keep making partitions from I to K plus nah, this will be math dot max. This partition, comma the other partition DFS of K plus 1 till yeah J. Yep, yeah. And then return result. But I need to write some logic here, right? Basically, if this is the case, then return 0. But otherwise, I minus k, I minus k. Oh wait, we need max. No, 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 no. If k minus, no, we don't know what k is now. Yeah, if j minus I plus 1. Um, if this is even, I think this will go here. If this is even, break it down. If this is DFS of this I comma j plus um, 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 if a segment has even continuous split into two contiguous paths, right? But what if it is not? This is just what if a segment is not even? Now, we add a cost here. What is the cost? From this range to this range, what is x? We need a prefix thingy, int prefix, and then basically it stores the number of ones. Uh, new int for int I equal to 0, I less than n I plus a prefix of I equal to a prefix of 0 equal to s dot char at 0 equal to 1, then 1, else 0. Prefix of I minus 1 plus ask the same condition. But here this will be I. So up till this point, what is the number of ones that I have? So this is basically inclusive one, right? Inclusive condition. So prefix of k minus prefix of I minus at 0. 1, and this is I. Yeah, this makes sense. Okay. This is basically x. This is basically x into ENC cost. ENC cost and flat cost. This dot is this, and this dot flat first equal to flat first. This is k minus I plus 1. This will be same in left equal to just simplifying things. Right. Okay. So this will be j minus k plus 1. Then prefix of j plus 1 till k plus 1 into incos. Perfect. Now, what if I cannot make further partitions? Else, result equal to math dot max of, just calculate this current path, right? Result and I mean, this is if equal is greater than, oh my god, if x is greater than 0 and x equal to 0, this is x, this the big else flat cost x greater than 0 than this, otherwise flat cost. If it is not crazy, I think this will be a constant for both, right? Oh, no, 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 no. Yeah, so just get these values and then left plus right. Then the return result. Okay. Wow. Oh, my bad. Yeah, you don't need this. Oh, yeah. And this can be one as well, but yeah, let's see. For now. Oh my god. From now. Yeah, this should be long. This should be long. Index. This should be long. Oh my god. And they're gonna be applied to given types. Oh, I forgot the S. Here. Yeah. Anything else? Ah, why is it returning zero? Let's see. What is wrong in my code? So, why is this wrong? Oh, if I is greater than different, different behavior. Um. Oh, wait. Where is the fourth loop? Where is the fourth loop? I plus one, and I think it should be less than k as well. less than k. Oh, wait, because of this? Nah, still the same. Wait. We need, oh no, we need minimum. We need minimum. Where is the result? How did I do that? Wrong route, max value. We need the minimum. We need the minimum. Doing. Oh, what? Oh yeah, this will become -1, right? Because it's in a bracket basically. Isn't it splitting the two equal halves only? Oh, no. Oh, oh, oh. How did I miss through that? If this is even, then divide it into my equal I plus j by 2 made and then made plus 1 till j. How did I miss that? What? Oh, yeah, it should be j plus 1. Okay, we don't need the else part. Your result website to minimum to j. This is correct. Where did you have the cost? This is hmm, cost of aid. Yeah, we don't even need this. Right, result equal to This range. Yeah, while backtracking, we compute this. Cost of I comma j public long cost int I comma int j. Hmm. Int x equal to prefix of j. Wait, what did they do? Yeah, that's way better. I plus one. Hmm. Zeroth index. I plus u. Oh no, no, no. I plus one equal to this index. Zeroth index is stored at an index ahead. Yeah. So this plus one minus prefix of I until L equal to j minus I plus one, and then um if x equal to zero, return flat cost, otherwise return L into x into PNC cost. We have this. This should be long. This should be long as well. Okay. If this is zero, and I return long dot max value. Oh my god. Yeah. Why? Cost is flat cost, which is what is flat cost? It is 10. Flat cost is 2, 0, 2. This is 0, 2 plus 2, which is 4, not good. Answer 4 is 6. Why is it returning only the flat cost? Do do I check this when condition? I should, right? Oh, Result, comma, you may say into two container equal length and the cost of this split is the sum of the cost of the resulting segments. This was a straight up DFS recursive problem. Ah, I get it. What is this? Yes. This will clearly makes sense. 10 power 5, this is I comma j, which is 2 power n, which is 2 power 10 power 5, which will obviously give a TLE. What's next? We memorize this code. Long dp equal to new long n, and this is also. Yeah, yeah. For int dp in the dp of this. Arrays dot fill dp with -1. Okay, this will basically never be able to FDP of I comma j is not equal to -1 immediately return dp of I comma j dp of I comma j is this. Ah, did this mess up anything? Probably. Yeah. Oh my god. I'm so used to autopiloting this now. This is so bad. Yeah, this is good enough. But is this correct? Like, is the DP correct? Incorrect base case. What happens in a later or use if since I already worked? Hmm, let me take wait for this. Mm, yeah, that's it, right? Yeah, some okay. Yeah, I need to understand why this base case never reaches. Mm, It's probably, I mean, why does this condition never reach? If it never reaches, then how does the base case return the value? How your recursion splits? Ta-da-ta, 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 ta-da-ta. Explain phrase. Take a string. Ta-da-ta. 0 to 1, 2 to 3, 0 to 0, 1 to 1, ta-da-ta, ta-da-ta. Also length 1 or so no split. Oh, so directly, data. Okay. Let's hit submit. There you go. Wow. Ah, Emily. Perfect. How do we prevent this? Oh, wow. How can I uh, mm, oh, 160 GB. Then how do I store my DP? The strategy is no DP. Is this login? Is the time complexity for this login? I think so, right? Because yeah, because we are just dividing it by two. Keep dividing it by two, and if the length ever becomes odd, we just never go ahead and divide it. Like, okay, interesting. Yeah, nice. Nice. Yes, code. This was a good problem. How much time did I take? Let's check. Okay, I think I should submit it. But I need to write some logic. The cost. An index ahead. Kind of there's a multiple segments of I equal to 0 means the ith element is sensitive and God, wait. Let me uh just check one thing. Okay. I think I can share my screen now. Yeah. Let's see. When did I start solving this problem? Even length I. Okay. Hopefully my camera wasn't lagging. 6 pointer problem. Hmm. Minimum cost of partition the binary string. Okay. 50 around 50 minutes. 52 minutes. I would say 50 minutes. 58 and then gotten accepted. Nice. That was yeah. Approximately 50 minutes, right? That is so slow. That is. So if I equal to 0 means well, segments I is sensitive and God, it what? And then got God, go live. Oh my God, troubleshooting. That is so slow. Approximately 50 minutes. That was yeah. Approximately 50 minutes, right? That is so slow. That is. Okay. Let's solve another problem. First, let's just direct in our GitHub. Ah, okay. What? Players. Hmm. Okay, let's see another. I do want to see what how Larry solved this problem. Just to get how he thought about it, how he approached the problem. Yeah, so that's the next
Hey everybody, this
one.
is Larry. This is me coming Q4, the weekly kindness 492, minimum cost to partition a binary string. Hit the like button, subscribe, or join me in Discord. Let me know what you think about this one. Honestly, I don't know why or what is going on with this problem. I think there's a lot of weird reading things, and I actually end up taking about 6 minutes on this problem, and about 3 of those minutes is just me trying to figure out how to read this problem. The thing is that the commentary is that if this if statement, but they don't say what's with an odd statement, they could just be explicit about it. And of course, all the examples don't really have an odd length case, even a subcase, other than one count, I suppose. It is very weird. I don't know why they do it this way. I don't know if it's supposed to yeah, it's just very weird. It's very confusing. I that's why it took so long. But otherwise, honestly, I don't really know how to talk about this because I don't think this just case other than one count explicit about it. And of course, the commentary is that if statement, but they don't say what's with an odd statement, they could just be explicit about it. And of course, the the commentary is that if this if statement, but they don't say what's with an odd statement, they could just be explicit about it. And of course,
Hmm.
they just all the examples don't really have an odd except
Yes,
the
yes,
odd
that is
length
true.
case, even a sub case. Other than one character, I suppose. It is very weird. I don't know why they do it this way. I don't know if it's supposed to um, yeah, it's just very weird. It's very confusing. That's why it took so long. But otherwise, honestly, I don't really know how to talk about this because I don't think this is that hard. The key part is just complexity analysis. Because well, there are two things. One is that you have to pre-calculate something, but then second is that it is complex analysis, and you have to think that. I mean, I think it is very easy to think, okay, well, we do take no take, and as a result, maybe two to the end or something like that. But keeping in mind that this is a classic divide and conquer recurrence, right?
Hmm.
And here we have it, right? Yeah. So here, let's ignore the prefix sum for now, so then we play around. But this is strictly a divide and conquer problem. We have the left and the right. We figure out the L. L is given by problem is also the length. X is just the sum. Is the let's say is a prefix. Do the fact cost.
Yeah, basically, he did exactly what I did. Okay, let's solve contest problems from weekly contest 491. Let's go. Trim trailing vowels. I have not solved this problem. Okay, 3856. Oops. 3856. 3856. Let's go. You are given a string as I consists of lower English letters. Okay. English letters. Return the string obtained by removing all the trailing vowels from S. Okay. Hmm. Okay. Parent I equal to minus 1 and n equal to start 1 I is greater than equal to 0 minus if s dot char I is not equal hash set a character set hash set if set dot contains if it does not contain the rate y equal to 0 oh minus 1. What is this? Ah, no. I accidentally pressed the submit button. I tried moving to the next line. Uh, I accidentally double tapped command, and then to remove this series, I double tapped command again, and then I don't know how. My brain just pressed enter because I wanted to go to the next line, and then it was so quick that I accidentally pressed command and enter together. Ah, 3856. Oh no, that is so dumb. Never mind. Huh. Return s dot substring from 0 to minus 1. Great. Oh wow, I never missed. S dot R A E I O U A E I O U I O U I O U. Yeah, I can also write this as cat. Oh no, I cannot. Yeah, this is better. Anyways, why is this slow? Yeah, okay. I didn't want to like write that big line. That's why wrote it in this manner, but yeah, whatever. Okay, next question. Minimum cost. Minimum cost is split into ones. You are given as an integer n and one operation known as selecting integer x into the positive integer. Six. 5 into 5 is 25. 6 into 4 is 24. 7 into, oh no, 5 into 5, 6 into 4 is, yeah, 7 into 3, 21. And total cost, that is split this into n ones, okay. 1.2, just two, this is basically 2, okay. For 4, it will be 3, okay. Oh, is there just factorial? Oh no, it's 500. For 4, it is 2 into 2, which is 4. Initial was thought was to divide it into two parts. Oh my god, didn't start it on. Was to divide it into two parts, but I don't think it will the optimal minimum total cost basically. While n is greater than 0, um, into result equal to 0. Result plus equal to and divide by 2 and divide by 3. The sum this result plus equal to n into n. But now we can have two different options. Well, we got one wrong. And then, yeah, this is it. Return result. One, 3 by 2. Yeah, this needs to be n plus 1 divided by 2. इसमें the upper value or the seed value basically. Make it pixel. Oh, n plus 1 by 2. Is that it? It should not take this long. How is it really? I'm literally just dividing it. I thought of using DB, but I didn't want to use DB. Mm, split the current x into 1 and x minus 1. I even thought of this. That's why I said uh, that that's why I said is it like factorial or something like that. But um, we cannot remove the factorial of 500. The row is always the same. What? Oh, it's not factorial, it's addition. 3 into 1. Oh, no. Genius. Oh, it's addition, not n minus 1. Now let me just int n equal to n minus 1. Return n to n plus 1 divided by 2. So that's it. That's it. That's it. Thought of it. Literally thought of the answer. Oh my god. Ah, that is so stupid. So if I equal to 0 means broken. That is so slow. 1 and it's 1. Return minus not. Oh, and oh, okay. I want to rewatch my reaction. This can chill out. This can chill. YouTube, YouTube, YouTube. Love this. Ah, I love this. It got captured on cam. Okay, okay, okay. Let's unpack this. Right. So here I'm basically reading. And seeing this formula right here, right? I'm thinking, yeah. N into n minus this. I know this formula. This is summation of first n natural numbers, right? Yeah. I'm reading. I'm thinking that in my mind. That's what I'm thinking. And then the realization point hits. Oh, it's not factorial, it's addition. 3 into 1. Oh, yeah, that's what I said. 3 into 1. That is addition. 3 into 1 plus 2 into 1 plus 1. No. Um, I'm a genius. I am a genius. Oh, it's addition, not n minus 1. Now let me just. I was so fed up. I could have written it in one line, but nah, I didn't want it to. One. So that's it. That's it. That's it. Thought of it. Literally thought of the answer. Oh my god. This is so funny. Uh, uh, okay. I will be back soon. I need to go to the washroom. I will be back soon. Till then, wait to tell you. Hello, hello, I am back. Yeah, after that uh, mess, I made it a boutique. Where is my Leetcode? Ah, there it is. Hmm, let me bring the camera back at its position. Um, okay. Minimum bitwise or from get rig. Okay. You're going to the integer it. Oh, I should. Okay. You must select exactly one integer from each row of the grid, return an integer in minimum possible bitwise or of this that shared integer from each row. Nice. Is it like just taking min values from each row and I think M into N is big. Yeah, it is big. So we cannot like iterate over the entire elements. Uh, or we can one way we can solve it is like we have to visit all the rows, right? Which is 10 to the power of 5. But we can use binary search. Why am I speaking about that? We can use binary search on the columns to get the minimum value. That's something we can do. Yeah. Is it just like minimum values or the number should be close enough for it to get cancelled? So I think yeah, that's the move, right? The numbers that we select should be close enough to each other so that maximum number. Oh wait, this is odd. Numbers bitwise odd. Okay, so yeah. Why did they take 5 and 4? 3 and 6. Let's just see. What is 3 in binary? 0, 1, 1, 0. 6 is 1, 1, 0, 0. Their odd will be 1, 1, 1, 0. Okay. 3 or 4. This is the worst possible combination. 1, 0, 0, 0 and 5. 1, 0, 0, 1. This is 4 plus 1, which is 5. Yeah. Hmm. Basically, what we need to find is a minimum number of ones and zero combinations. Here we have 1, 2, 3, 1, 2, 3. Okay. And what I am thinking of uh is basically to find minimum number of 1 and 0 pairs, right? How do we find that? Using XOR probably, right? Because no, but that will not give me the same like the number of 1 and 0 pairs. It will give me a different number. Huh. Hmm. Interesting. we cannot do like one uh, or two and then one or two and four. Basically, check take one element and check with other. That's like n square, which is not right. So, oh wait, I meant uh, m into n. M cross n is basically less than 10 watts. Hmm. Is it just an enumeration? Like finding brute force basically. Just take one element and then keep on doing the OR with all the other elements. Ah, current R equal to grid dot len and C equal to grid of 0 dot len for entire equal to 0 and less than R I must press for okay. For int j equal to 0 j less than CJ plus plus. Okay. Int selected. This number has been selected, right? Uh, which is grid. Oh, we have this. What is- Ooh, I think this will go recursive. DFS grid I comma J in RC is public int DFS int grid int I int J. This will be start from 0, then check for uh, like uh, first check for 5, then take first take 1 as the current element, then 5 as the current element, but we cannot go for 2, right? Because we don't want to move up. Yeah, this I think this is 0 comma 0 here, and then if at any point I equal to r and r minus 1, j equal to c minus 1, we return what do we want to return? We return the num int num equal to how will this know what num is? Um, int num equal to 0, and this will return num. Okay, what is this? If I take the first element at each row, if I take this element, so num equal to grid of I. I do need a for a second for truth. For int j equal to 0, j less than c, j plus plus. I comma j or DFS of grid I plus 1 comma j. Comma j, yeah. Next row, and then choose whichever j you want. Choose whichever j we want from that position. Int small r equal to I, yeah, r is less than capital R and r plus plus. Now, here int c equal to j, c is less than success, c plus plus, huh. This is r plus 1, and then this sort, but we need math document of num commas. What? Oh, my bad. Return num. Oh, return. Oh my god. Yeah, why is it returning 0 though? Probably because of this. What the? Oh, 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 oh. Not sorry. Never mind. Never mind. This never even works in the day. Why is this wrong? Pick exactly one number from each row. Include the bitwise or of all the chosen numbers. Uh, what? Yeah, and then return 0. Yeah, Yeah, only iterate over the columns because we are already iterating recursively via this the rows, right? Yeah, just generate all. Yeah, this will be answer. This will be answer. This is I comma C. I plus one. Oh, you only have, yeah. Wait. Well, yeah. R in this row, I checked over all the columns. So this is R plus one. Small r equal to capital R. Equal to. What? Yeah, this should be unsure. Mhm, mhm. Yeah, this should work. Yeah, this. Oh my god. This was actually not that bad of a problem. Could I have done uh, solve this problem? Oh, okay. Anyways. Oh wait. I have to memorize this. I should have memorized this. This will give a wait, what? Wrong answer? No, I don't even need to memorize this. But why? Yeah, because this is M cross N, R cross C, which is kind of within limits. C power R. Hmm. Bye. Wait, do we not make the minimum? Yeah, we do. This is current or grid of partners. Yeah, that does make sense. This is the current state, right? Return is equal to math dot when answer and current. Mm, yeah, nice. Will this give me a TLA? Yeah, yeah, yeah. Nice. Just draining through my uh acceptance rate. Oh no. I should have minimized this. Um, Mm. Wow. Mm. I get this. The problem is memorization. This it can be solved using bits, I suppose. It's wow.
Else, you do the
3858.
hey everybody, this is Larry, this is Miko Q3 of the weekly contest 491, minimum bitwise or from grid. Hit the like button, hit the subscribe button, hit all the buttons, leave a comment. For this problems like this, and I feel like recently there have been many similar problems, so I think this is for me not super tricky. I think the problem that I would say if this problem is tricky for you is that that while the ideas are the same, I think the thing with these bitwise numbers problems is that it's all about the idea, right? And if you've been learning because of, or you've been learning via memorization, either intentionally or not, by just memorizing patterns and all these things, it's
Yes.
possible that you miss some of the ideas, or at least you don't learn in a way such that you're able to kind of come up with new solutions or whatever, new to use solutions or whatever. And as a result, it becomes really hard. But the core idea behind these bitwise
That's literally what happened right now. That's exactly what happened right now.
problems often is greedy. And what I mean by that, what I mean by greedy is just that you're trying to optimize it in a way. Well, okay, let me step back a second. the core idea behind bitwise operators is that they do the bits, the numbers and the bits, or the digits and the bits and the digits, whatever. They don't affect each other, right? What I mean by that is, let's say you have like two numbers, and I'm just gonna write them in binary, and that's not the push. Two binary numbers, right? Whatever. You just kind of always kind of greedy on the most. It depends on the problem, obviously. Still, it's not always the case. But if you're trying to maximize or minimize, it's always going to matter. It's greedy in the sense that you always want to optimize for the most significant bit first, right? And what I mean by that is because, well, it's obvious, right? Because you could have, if you have and you have it doesn't really matter what the rest of the numbers are. If, because this number, you can compare the rest of the number by just this number. So you're always going to be greedy in that sense of caring for the first number, right? And I've seen somewhere that, at least in my Discord, people call this, or they look at the code and it's way similar to binary search. There are a couple of ways to write binary search, right? But there's one variation of binary search where you look at the first bit at a time. And in that sense, if you just look at the code without the proper understanding, you may call this binary search. And not to say there isn't a binary search answer, but, visualization is not code and code is not visualization. I think sometimes people go, okay, well, if it's this, then the code looks like this. And then also, if the code looks like this, then this is an X algorithm, right? And it's an easy mistake to make when you, I wouldn't say mistake, sorry, my apologies. But it's an easy shortcut to take, but you might not be aware that it's a shortcut, and sometimes it happens. And we look at the code, and we'll go over the code in detail, or at least in some detail later, my code anyway, and it looks like binary search, but it is not. What I'm doing is that I'm just looking at it one bit at a time. I'm looking at it, okay, well, if I'm comparing these two numbers, then I know that this number is good, right? And then what I'm doing is that, well, now I'm looking at the next number, right? Is it a 1 or a 0, right? If there's no ones, well, now I'm looking at the next number, right? Is it a 1 or a 0, right? If I'm doing one bit at a time, I'm looking at it, okay, well, if I'm comparing these two numbers, then I know that this number is good, right? And then what I'm doing is that, well, now I'm looking at the next number, right? Is it a 1 or a 0, right? If there's no ones, then it's a 0. So that's basically the entire structure of the problem. That's what I'm trying to do. So all I've been explaining so far, honestly, is not related to this problem per se, but it's just a general idea for these bitwise problems. Right, it could be bitwise or it could be bitwise and it could be bitwise XOR, right? Like, it's bit at a time, and we are trying to minimize and maximize these things. And of course, you do handle OR and XOR differently because it just has different implications. We won't go into all kind of details with that, for this problem, but we'll go with respect to OR. Well, so in this problem, we have OR and we're trying to do minimization, right? What does that mean? Well, that means that, there's only 3 cases or 4, depending on how you want to do the loss of generality, right? You have to do, and do, right? Yeah. So you have these things, and you have an OR function, right? And you're trying to minimize. So then when you're trying to minimize, then the only question is, can this happen? If this cannot happen, then you leave with one of these two, which leaves you with a 1 in the digits, right? And of course, as we said, because we're trying to minimize, we're trying to just see if it is possible to get a 0. And for this problem, what does that mean? That means that, okay, now you have a grid of numbers, right? And you're trying to pick a number from each row. Okay, so then now we start with the most significant bit, right? The first bit. Okay, now you have a grid of numbers, right? And you're trying to pick a number from each row. Then you get a 0. And of course, as we said, because we're trying to minimize, we're trying to just see if it is possible to get it, right? And then you leave with one of these two, which happen, and you're trying to minimize. So then when you're trying to minimize, then the only question is, can this happen? If this cannot happen, then you leave with one of these two, which leaves you with a 1 in the digits, right? And of course, as we said, because we're trying to minimize, we're trying to just see if it is possible to get a 0. And for this problem, what does that mean? That means that, okay, now you have a grid of numbers, right? And you're trying to pick a number from each row. Okay, so then now we start with the most significant bit, right? The first bit. If we can we create a 0 from the most significant bit? And that's all I'm doing. I go through every number and I go, okay, is there at least one number that I can pick where, the 0 can happen? Is there, and then if I can pick one number from each of these, well, at least one, right? It doesn't have to be just one, but if it is possible, then we can have a zero. If not, then, right, it doesn't pick one number. Is there, and then if I can pick one number from each of these, well, at least one, right? It doesn't have to be just one, but if it is possible, then we can have a zero. If not, then the prefix is a one, because it doesn't matter what anything is. You just have a one. You're gonna have a one anyway, right? Okay. So that's one digit. So then now the question is, how do you continue on, right? So let's say we have a prefix of one. Actually, yeah, let's say we have a prefix of one. What does that mean, right? And then now we're trying to figure out the second digit of it, 0 or 1. Well, then now we look at all these numbers, and because the prefix is one, we know that the prefix just allow us to set the filters, if you will. And maybe you could actually like actively remove them from the list, actually, but but then you have to go back, and I don't know. But there's a no. Well, one. What is, right? So let's say we have a prefix of one. Actually, yeah, let's say we have a prefix of one. What does that mean, right? And then now we're trying to figure out the second digit of it, 0 or 1. Well, then now we look at all these numbers, and because the prefix is one, we know that the prefix just allow us to set the filters, if you will. And maybe you could actually like actively remove them from the list, actually, but but then you have to go back, and I don't know. But there's an active filter, right? Which is that now, for every of these numbers that you're comparing, you actually, we're looking at the second digit, but we're also looking at the first digit, right? And prefix before that in the future. And what this is saying, because this is a 1, means that the first digit can be a 0 or 1. Because it still will get the same answer if it's 0 or 1. So that's basically the idea. And then now the question is...
Okay. Hmm. That was a uh, problem that was like not known to me, like the concept of it. Like I'm looking at the problem right now. It is a good problem. Never solved it. Never solved such kind of problem. A bit difficult to digest. I don't know. I think Vivek Gupta has recently did a live stream, right? But I believe we went over this problem. I just need to find it. This is like weekly 491, I guess. Okay. Yeah, weekly 491. Uh, 491. Okay.
which has greater than m frequency in another variable. So what we can do, and each, okay, no matter what is the frequency, that doesn't matter. Like you will just
Ah, okay. It is almost like uh okay, this open. Ah, it's almost 7:20, right? It's 7:20. I have a bi-weekly contest actually. Like for bi-weekly contest, I need to eat some food, like, and then we'll give the contest from 8 to 10, 8 to 9:30. right? So I'll probably be a short live stream, 3 hours, 30 minutes, almost. Hmm. Okay. I think I don't know if uh I will definitely not be consistent for live streaming, but most probably I will stream this year, like in between. Like I didn't even notice like 3.5 months went by uh of 2026. I'm in second year right now. My fourth sem is going on right. Yeah, by the way, today was the last day for my ISC exam, in-sem exam, or mid-sem exam, or whatever you want to call it. But yeah, second year, fourth sem, uh, my ISC is over. I am nervous. Don't know what's going to happen in the future, but uh, hopefully, hopefully it goes well, right? We'll see you. Uh, Probably, I don't know, within this year. But yeah, till then,